go. Okay, so number 1 has more than one operation, right? It's got a division, obviously, and it's got an addition. So according to the order of operations, what has to happen first? Division. And if you are taking a fraction divided by a fraction, what's that little phrase we talked about? Copy dot flip, copy dot flop, however you want to say it, or maybe you have another one, but you got to be able to do that, right? So I'm going to go copy dot flop or copy dot flip. So that's my first step. I'm just going to turn that division into, change that division into a multiplication and flop the second fraction. So then whenever you are multiplying fractions, you can cross cancel, right? Maybe you did this at the start. Doesn't the 15 and the 5 cancel out with each other? Yeah. And so the 15 would cancel down to be a 3. The 5 would cancel down to be a 1. And this would give me, as now I multiply my fractions, 3 times 3, which is 9, and 1 times 4, which is 4. So I get 9/4 plus 3/4. And wow, check this out. In order to add fractions, what do you have to have? And look, you already have them, right? You didn't have to do any extra work. 9/4 plus 3/4 is what?
12/4.
And 12/4 is also known as?
3.
3. Your final answer, final value for number 1 should be 3. Any questions on number 1? Yes, ma'am.
Is it okay if you didn't cross cancel?
Yeah, totally. You could always reduce later, not a problem. I usually do that at the start just because I'd rather get things simpler at the start, but you could definitely do it the other way. All right, number 2. Number 2 says simplify completely. And I think, honestly, the easiest way to simplify, number 1, first step is to look for any distributive properties. Do you see any? Sometimes they'll be there, sometimes they won't. What's being distributed on this one? -6, not 6. You guys said it right. It's -6. So the -6 gets distributed. This gives me 9 minus 6x. What's the next symbol? Not minus.
Plus.
It's plus, right? Because we're doing a negative times a negative, which is positive. So it'd be 9 minus 6x plus 30 plus 2 minus 8x plus 7x squared. As a final step here, I've just got to collect my like terms. And I'm going to go in order of exponent here. What is like the 7x squared?
Nothing.
Nothing. No like terms, so I'm just going to copy that down into my final value here, 7x squared. What is like negative 8x?
-6x.
Negative 6x. When you add those up, what do you get?
-14x.
Awesome. And then, would it be fair to say that the remaining terms are all like terms, the 9, the 30, and the 2?
Yeah.
When you add those up, you should get 41. So there's your final value, your final expression there. Any questions on 2? Okay. Number 3 then. Notice how, do you see how, I mean, let's be honest about this. When you just look at numbers 2 and 3, don't they look really similar? Do you see how somebody really could look at this and look at this and feel like it's the same thing? Why is it not even close to the same thing? What's the one thing?
Because there's an equal sign in the middle of one of them.
That's it. One of them has an equal sign and the other one doesn't. So the one that has the equal sign, that allows you to actually use that word. Something that has an equal sign, you can actually find a solution for it. Something that doesn't have an equal sign, you can't solve. You can't find a solution for it. Okay, so even though these are radically different statements, the first step is actually the same. We need to simplify first. So looking at number 3, any suggestions on what kind of simplifying could or should be done?
The negative sign.
The negative needs to be what? Distributed. So this negative gets distributed through here and here, giving me 2x minus 5x minus 8 equals 7x plus 11. Now remember, the first step when you're solving is to get all the stuff that can be simplified, simplified. So do you see any other simplify things? Oops, sorry. Any things that could be simplified?
No. The x's can be...
There's a bunch of x's, yeah. So the 2x minus 5x, what's that?
Negative 3x.
So it'd be negative 3x minus 8 equals 7x plus 11. Any other simplifyings that could be done? I think technically there is. I need to move something? Okay, I could add 8 to both sides. I could get started with that. So I'd go plus 8, plus 8. When I add 8 to both sides, I get negative 3x equals 7x plus 19. And what Chase suggested is fine, but I still have the same issue, right? What's the issue I have? Yeah, I got an x on the left side. I've got an x on the right side. How is it that I deal with that? Definitely not divide. I need to combine, right? So I need to either add something to both sides or subtract something from both sides. You guys suggested that I subtract 7x, and that's fine. That gives me negative 10x. And then, of course, the 7x minus 7x is 0 equals 19. Finally, I divide both sides by negative 10, and I get x equals negative 19 tenths, or 19 over negative 10. That would be my final solution there. You can obviously check that by plugging back in. We're not going to do that right now. Sorry, I don't know what the technical glitch is, but that keeps blinking on and off. Look at number 3. Look at what you have. Look at what I have. Do you have any questions? If you have negative 1.9, that's fine. Negative 1 and 9 tenths, that's fine. I kind of like that, but those other answers are fine too. Okay. So then, lastly, number 4, sorry. Domain would be all of your x values. So this would be 5, negative 3, 4, and negative 1. Do you see how the 5 is repeated? I do not have to list it twice. It's just part of the domain. My range would be all my y's, negative 9, 8, the negative 9 again, 7, and 2. That's my domain, that's my range. Remember, domain goes with your inputs or your x's. Range goes with your outputs or your y's. And then lastly, for B here, it says, is the relation a function? So first of all, yes or no? What do you guys say?
No.
You say no, okay? And the explanation, what is the offending input? 5 is the one that ruins it, right? So explanation, you could say the input of 5 has how many outputs? 2. Has 2 outputs. And because a function needs to have inputs that have exactly 1 output only, 2 is not 1. So making this not a function. This would fail the vertical line test. Okay, again, take a look at your number 4, A and B. Look at mine. Compare. Maybe it's your explanation. Maybe you didn't write down an explanation. Is that something you're going to need to know how to do? Definitely. Maybe your explanation is worded a little different than mine. That might be okay. Happy to field any questions you guys have. Okay, fair enough. Thought it was worth going over those quizzes for sure. All right, so here we go. Our class examples. Number 1 says, create the graph of, the linear equation y equals 2x plus 1 by creating a table of values. Sometimes your book and your web assignment is going to say a table of solutions. And I think that is bless you. I think that is also a nice way to put it. So we're going to create a table of solutions, and we're going to try to plot those points. What I've done is I've set up a nice set of inputs for you. The x's are negative 5, negative 2, 0, and 3. The truth is we could have chosen any numbers that we wanted to. I just set some up for you. So let's go ahead and see what we can get for our table of solutions. What I'm going to use is y equals 2x plus 1. And I'm just going to go input, output, and we'll create this table of solutions. So the first input for me is negative 5. So if I take that negative 5 and I plug it in here for x, I'm going to get y equals 2 times negative 5 plus 1. Follow order of operations, that would leave me with negative 10 plus 1. So if my input is negative 5, what's my output? Negative 9. So I'm going to put that in there with my table of solutions. My first solution is negative 5, comma, negative 9. Any questions on how I got that? Plugging in the input, getting out an output. Okay, so then the next one is a negative 2. This would be y equals 2 times negative 2 plus 1. Again, following order of operations, I get negative 4 plus 1. So that means when my input is negative 2, my output is? Negative 3. That's my second solution for this linear equation. What's the next number I'm going to plug in? 0. All right. So it'd be y equals 2 times 0 plus 1. Following order of operations, what do I get? 1. If you haven't already tried it, please try to figure out the final output. If the input is 3, what is the output? Completing our table of solutions. Okay, guys, just shout it out. What do you think it is? 7 is right. Okay, so this table of solutions is also a set of ordered pairs or points that define this line. So my first point is negative 5, negative 9. So starting at the origin, I'm going to go left 5, down 9. So my first point is right here. Negative 5, comma, negative 9. I'm just going to plot these points out. X's are lefts and rights, Y's are ups and downs. Then negative 2, negative 3. So that's left 2, down 3. That's right there. 0, 1 means go left or right 0, up 1. There's that point. And then 3, 7. You watching carefully? What did I do wrong?
You swapped the...
Didn't I actually graph 7, 3 instead of 3, 7? So make sure you're really careful with that. See that happen sometimes? 3, 7, it's right about there. Okay, so then what I would do, since I am graphing a linear equation, is I would try to connect all those with something resembling a straight line. Should be arrows on the end of that line. What do the arrows indicate?
Keeps going.
Goes on forever, right? It's infinitely long. That'd be the graph of my line. Did that by creating a table of solutions and plotting each of the points. Okay, any questions? Okay, awesome. So then moving on to example number 2. Says, is the point negative 2, 5 on the graph of the line y equals negative 1/2 x plus 3? Show the work leading to your answer. So we just graphed the line based on plotting points, right? So what I'm asking you is, if I graph that line, y equals negative 1/2 x plus 3, would the point negative 2, 5 actually be on the line, or it would be somewhere off the line? Any suggestions on what you think we could do to decide the answer to this question? What do you think, Ben?
Plug in 5 for y and negative 2 for x.
Because that's what they are, right? It's x comma y. Okay, so let's try that and see what happens. So 5 goes in for y. Negative 2 goes in for x, as Ben suggested. What do you think we should do with this? We did what he said. Like, go ahead and do the arithmetic, right? Okay, so what's negative 1/2 times negative 2?
1.
Positive 1. And of course, 1 plus 3. Ooh, we have a major issue. Is that true?
No.
5 definitely does not equal 4. So all of these are actually false. So since that did not create a truth, what's the answer to the question? Is that point on the line? No. So our final answer is no, that point is not on the line. The reasoning is the steps that I just showed. When I tried to see if the point actually is a solution for the line, it proved to not be, right? It gave you a false statement. Okay, any questions there? This is just like checking an equation solution. Just plug it in, see if it's true. Okay, and then 3 says for the linear equation 2y plus x equals 8. So this is a little bit of review here at the start. So question A. This was one of the ones we struggled with the most on the concept quiz. I think it was number 5, one on the far right, where it was like P equals 2L plus 2W, solve for W. Some folks just left that one blank. They're just like, don't know. So this is kind of a review of that. So if you see the words solve for y, what does that mean? Isolate. That's what I want to see. Or get the y all by itself. Okay. So I'm looking at this 2y plus x equals 8. Okay, what do I got to do? I got to get the y by itself. What's with it?
Subtract
There's an x with it, and he says subtract x. What else is with the y? So should I take Coy's advice and subtract x first, or should I do something with the 2?
Subtract x
I
first.
need to subtract x first. Coy is right on the money. So I'm going to subtract the x over. So I get 2y. What is 8 minus x? Those are unlike terms, right? Totally unlike terms. And so 8 minus x, my friends, is just 8 minus x. Can't combine anything down. It's just simply that. And then our last step is to get rid of the 2. And to get rid of the 2, what do we need to do? That's where you divide by 2. Division will frequently be your very last step. Rarely will it be your first step. Every now and then it could be, but most often it'll be your last step. So y equals 8 minus x over 2. Or if you wanted to, you could say that it's really 4 minus 1/2 x. Same thing. Dividing both terms by 2. Okay, and then lastly here I've created a little table for you. And it says, graph the linear equations by creating a table of solutions. In the top here, I'm going to put x, y, and then over here it's going to be x comma y. Just a way of kind of organizing your thoughts. And here, I have not given you guys inputs, and so I want to get some of your guys' input on what our inputs ought to be. I just want to let you guys know. We can pick whatever x values we want. Like if I said, hey, what x value do I want to plug in? And you said 1,720,000.9. We could do that. That seems very unwise based on the scale of our graph there, but you could do that, right? So smaller numbers maybe would make sense for our graph because it's just plus or minus 10, I guess, or no, plus or minus 8 it looks like. So we'll decide how we want to handle this, but I want to look for your guys' input. But before we do that, I want to ask you, how many points do I really need to define this line? 5, 4, 3, 2, 1. How about 6 or 10? How many points? Like, think about it. Like, if I said there's a line going from here to there, how many points would you need to be able to understand where that line is?
2.
2. 2 points. So if I said, hey, I want you guys to get some tape, and I want you to use tape to draw a line segment between me and Joe, wouldn't that be enough information? Couldn't you just be like, all right, tape? You wouldn't be like, oh, but we need a little more information. Like, what's going on in between there? It's just a line, straight line right at Joe. Now, if it was going to be some curvy graph or something like some of the ones we've looked at, you would definitely need more information. But if it's just a straight line, all you need is the 2 points. Now, I personally am a fan of having at least 3 points. That way I feel a little more confident that I didn't make some little mistake. And so I'm going to suggest that you do at least 3 points, but 2 points should determine a line. So I'm wondering, does anybody have any suggestions on what an input for this could be? Ava?
0.
0 is always a nice thing to think about. And so we're going to start off with that. So 0, we'll use that one for sure. What do you think?
1.
1 is also a good one. Anybody have any other suggestions? 2. Why are you guys so afraid of negative numbers? Negative number would be good. So 2, how about negative 2?
Sure.
Don't be afraid of negative numbers. So of those 4 that are put up there, I think you're going to find that 3 of them are going to work out really nicely. And one of them is going to be a little bit difficult to graph. It won't be impossible, but it'll be a little bit difficult to graph. All right, so here's what I'm going to do. I'm going to use this as my linear equation, right? We solve for y. And I'm just going to go input, output, like we did at the start. So if I plug in a 0, I'm going to just squeeze this in over here. So there'd be y equals 8 minus 0 over 2. What's 8 minus 0 over 2?
4.
4. It's just 8 over 2, right? Okay, so if my input is 0, my output is 4. That means I've got the point 0, 4 on my line. What about when I plug in a 1? Get y equals 8 minus 1 over 2. 7 over 2. Let's go with a decimal here and make it a little easier to graph. 3.5. Okay, so when x is 1, y is 3.5. That means I've got the point 1, 3.5 on my graph. How about the 2? y equals 8 minus 2 over 2. 8 minus 2 is 6. Just do an order of ops here, right? 6 over 2 is 3. So that means the point 2 comma 3 is on my graph. And then the last one, negative 2. Wouldn't that be y equals 8 minus negative 2 over 2? What's 8 minus negative 2? It's plus 2, so it's 10 over 2 is 5. So we're just going input, output a bunch of times. Negative 2 comma 5 is on my graph. So which is the one that's most difficult to graph? Yeah, it's a decimal. Nothing wrong with that, just a little tougher to graph. So 0, 4 would be up here. 1 comma 3.5 would actually be right about here. 2 comma 3. Negative 2 comma 5. So I can see that that roughly follows a straight line. You know, I'm not a perfect drawer. Oh, I missed with one of my points. Let me go back. 2 comma 3 would actually be there. That's why you maybe graph more than 2, right? I missed. Make sure I just put arrows on the end. Okay. I wanted to take a quick look at what's coming up here. We didn't get quite to our practice. We covered everything we needed to. If you look in your practice questions, please don't pack up yet, because when you're packing up, your brain shuts off. There's still time. Still have about 3 minutes here. So please notice, there's just 2 of them. I don't know why it's numbers 1 and 4. Microsoft Word messed up counting. I know how to count. Microsoft Word doesn't, I guess. Who knows? So number 1 is like what we did earlier, I think, with number 2. And then number 4 is like what we just did. So I'd encourage you guys, if you want to get a little extra practicing in, you want to check and see how that went, that would be a great idea. That's right there. But basically, as you leave here today, we're gonna just sort of change our focus from graphing lines, because we'll do more of that next week. We're going to change our focus more towards, all right, well, now what about the unit tests on Wednesday? So tomorrow, listen carefully. Please bring some kind of an internet device in which you can work on your WebAssign. Okay, that's going to be our primary focus. I'm not going to play any games tomorrow or anything like that. We might go to the boards. We might do a few things, but I want you guys to get some real, honest-to-goodness work done on your review. So you might want to start on that because it's pretty big. But tomorrow, Q&A, working on that, getting ready for your Unit 1 test on Wednesday. Good? All right. See you guys.